Should type 1 diabetics aid perfect diabetes management? What do perfect blood sugars look like, and how do you know when you're there? If you've asked yourself similar questions, then stick around as we try to answer some of them for you today. Hello and welcome to the channel. I'm Curtis, and here we focus on upskilling your type 1 diabetes knowledge, skills, and mindset to make diabetes a little bit easier. So what does perfect diabetes management look like, and is it something we should all aim for? Well, unfortunately, the answer is perfect diabetic is a non-diabetic. Now, try not to get too discouraged, because by understanding how a non-diabetic manages blood sugars, you can elevate your type 1 diabetes management. In this video, we'll look at why you should care about non-diabetic blood sugars, how a non-diabetic manages their blood sugars, and how this knowledge explains one essential part of injecting your insulin. Why you should care about non-diabetic blood sugar. All of the diabetics that I had spoken to, no matter how tightly controlled their diabetes is, agree that when managing blood sugars, it can feel like the goalposts are always moving. I do one thing today, I do the exact same thing the next day, but end up getting two very different results. It can feel like absolute chaos. By learning about non-diabetic blood sugars, we can bring some order to this chaos. Understanding how the body functions with a working pancreas can give us a clear picture of when the body wants insulin and how it wants to use it. We can then try and copy this picture with our own manual insulin injections, be that via pen or pump, to try and improve our own sugars.
How do non-diabetics actually manage blood sugars?
This section might take you back to high school biology, but even if science wasn't your best subject to stay with, I'll be using plain and straightforward language to make sure this information is accessible to everybody. Alright, let's keep it simple. Your blood sugar can come from only two places. One, from inside your body, from your liver and muscle, and two, from outside of your body, which is the food you eat. From inside your body, your liver and muscles can actually send sugar into your bloodstream. From the outside, the food you eat, especially carbs and protein, are digested and added to the bloodstream as sugar. The sugar is turned into the simplest form of sugar, which we call glucose. Your brain and muscles in particular love glucose. They burn it for energy. Think of it as the fuel for your body's engine. But there's a catch. Glucose is quite large and can't move from the bloodstream into the cells on its own. It needs insulin as a helping hand. Insulin comes from the pancreas, and its job is to take glucose from the blood and pack it into the cells to be used as energy. Insulin is pretty commonly thought of as being here opens the door to your cells to let glucose inside.
And in this animation, we can see the largely pinky red cell, the white glucose floating in the bloodstream, and the blue flower shapes that represent insulin. As you can see, insulin comes over and sits on the trigger or locking mechanism on the outside of the cell, which unlocks the cell to let glucose move from bloodstream into the cell. And only once inside can the body use glucose as energy. In this next animation, we can see that there is no insulin, that's the blue flower, within the bloodstream. And this means that when glucose tries to get into the cell, it physically can't. The door is firmly shut and there is no insulin key to open it.
And if you only remember one thing from this video, it should be that insulin will always act to lower your blood sugar. Now, lowering blood sugar is important, but for all of us that have had hypos, we know raising them is just as noteworthy. So how does a non-diabetic body know when to stop lowering sugars and to start raising? So for our non-diabetic friend, just like us, when you haven't eaten anything in a while, blood sugars start to drop. This might happen while you're sleeping or exercising. Now, the pancreas detects these falling blood sugars and stops the production of insulin, which stops blood sugars from falling in the body. The pancreas then releases a second hormone called glucagon, which kind of does the opposite thing to insulin. That's because glucagon actually unpacks the glucose that insulin stored in your liver and muscles, and it pumps it back into the bloodstream. This may sound familiar because if you are a type 1 diabetic, you probably have a prescription for glucagon, which is usually a large dose of the stuff used in emergency low sugar situations or hypos to rapidly raise blood sugar. So the pancreas is like your body's thermostat, but for blood sugars. If blood sugars are too high, it sends out more insulin to lower them, and if they go too low, it cuts off insulin and sends out glucagon to raise them. The end result is that a non-diabetic keeps sugars roughly between 3.5 and 6.5 millimoles, or 60 and 110 milligrams per deciliter. And that's all done on autopilot. And gee, wouldn't that be nice? So insulin and glucagon are the headline hormones, if you will. But there is another one that doesn't get a lot of attention, and that's amylin. Amylin's job is to work with insulin at mealtime. It slows down food digestion and makes it take longer for the food that you eat to get into your bloodstream as glucose. This extra time allows the pancreas to produce more insulin and to enter the bloodstream, all of which acts to prevent significant blood sugar spikes post-meal for non-diabetics. Unfortunately, type 1 diabetics are not able to produce amylin. So how can all this knowledge help your diabetes? Apart from giving us a great direction to aim, that is to start thinking more like a pancreas, it leads us to an essential piece of info about injecting insulin.
So what is this essential insulin bolusing tip? Well, that would be pre-bolusing.
Because type 1 diabetics have no amylin, it means our food is going to cause sharper spikes in blood sugar. On top of that, insulin is injected into a fatty layer just under the skin and has to travel all the way to the bloodstream. This is opposed to non-diabetics whose insulin is directly pumped in the pancreas. So because we have blood sugar that rises faster after a meal and insulin that takes longer to work, we have to manually give ourselves a head start to avoid these blood sugars.
And that's why pre-bolusing is so important. Pre-bolusing is when you give your insulin 5 to 15 minutes before you actually start to eat. The exact timing can depend on your diabetes and the types of food you're eating.
Now, everybody is different, and I don't know you or your diabetes person. So before you make any changes to your mealtime insulin regime, make sure you talk with your diabetes healthcare team. If you're struggling to explain the value of pre-bolusing to your healthcare team, then by all means, show them this video. So that's a crash course in how the non-diabetic body uses insulin. It's really essential knowledge that gives us type 1 a blueprint to try and follow, while also giving us some great insight into why pre-bolusing is so important. Please let me know if you found this video helpful by clicking the like and subscribe buttons, and let me know in the comments which type 1 topics you'd like me to cover next. Hearing what you want to learn about helps me learn about my own diabetes and will undoubtedly help someone else with their type 1 diabetes. But you're doing a great job. Keep learning, and may the blood sugars be ever in your favor. See ya.